All right, this is the second of 3 videos on division. The first video on division, we talked about specifically TEKS 4.4e and 4.4f, and we talked about base 10 with division, just learning the concept of division and equal groups. We then talked about the arrays, creating arrays with base 10 and arrays with drawings. And then we talked about the area model and how that relates to arrays and how you can teach those at the same time. So today we're going to continue talking about 4.4e and 4.4f, but we're going to look at partial quotients and the standard algorithm. So let's say we have a problem, 673 divided by 3. Okay, when we're doing partial quotients, basically what we're doing is we're asking students to take out big chunks and do subtraction until they get down to either a remainder or a balance of 0, right? So that everything's in an equal group. I like to give students help with partial quotients, and we're going to do things like we're going to look, can I take out a chunk of 1,000, 100, 50, 25, 10, and 5. And they're multiples. I don't want you to think they just have to take out 1,000. They can take out 2,000 or 3,000, whatever they think works. So here I have 673. So definitely I can't put 1,000 in each group because I don't have 3,000. Can I put 100 in each group? Yes. So I can take out 100. 100 times 3 is 300. And I subtract it. Some students may have saw that I could have taken out a group of 200 and gotten 600. If they see that, great. If they don't, that's fine too. Remember, it's whatever is efficient for that student. And if I don't know my multiplication facts, doing multiples of 110 may not be what's efficient for me. So, can I take out another group of 100? Yes, I can take out another group of 100. 100 times 3 is 300, and that leaves me 73. Okay, can I take out 3 groups of 50? No, because I only have 73. Can I take out 3 groups of 25? No, that gives me 75. Can I take out 3 groups of 10? Yes. So I can put a 10 here, and I can take out 30. I can take out another group of 10, that's 30. Okay, I can't do a group of 10, a group of 5, no. So what can I multiply by 3 to get me close to 13? That's 4. So that is 12. And look, I have a remainder of 1 because I can't, it's lower than my divisor. So I add these up. So my answer is 224, remainder 1. Okay, so that is partial quotients. As I said, students can take out multiples. So let's say I have the problem 4,982 divided by 2. I know that 2 times 1,000 is 2,000, 2 times 2,000 is 4,000. That leaves me 982. I know 400 times 2 is 800. 182. I know that, let's see, 90 times 2 is 180. So that leaves me 2, and I have 1. And my answer is 2,491. So for me, that's pretty efficient. I can take out big chunks, or I can go by just my hundreds. I can take out multiples, or I can go by just 110, ones, and so forth. Okay? So that is partial quotients. All right, so now let's talk about the standard algorithm. All right, when you do the standard algorithm, I want you to go back and start with base 10. So let's think of a problem. 200, or actually do 320, 4. So we're going to do 324. And we're going to do divided by 2. Okay, so I would start out with base 10, just like I have. I'd have the kids get out 324. I'd have them draw or have a place on their table, maybe 2 sheets of paper or something where they could separate them into groups. But I'm also going to have my division symbolism here, because we're going to do both at the same time. So we're going to talk about, I have 3 hundreds. You see 300 here. How many hundreds can I put in each of the 2 groups? And they're going to say 1. So I put my 100 and my 100 into the groups. Perfect. So how many hundreds do I have? I have 100 times 2, which is 200. And I go ahead and place the entire value of that 200 here, and then we subtract. And that leaves me 124 here. Okay, students can see this process. I want them to see it. Then I say, okay, I've already put all the hundreds I can down. Now I have to do tens. What's here? It's 100. So what I need to do here, I need to regroup that. All right, so now I have 12 tens. Do we see that? Yep, we see 12 tens. Okay, so then we can put as many tens as we can in each one. So I would say, well, what is 12 divided by 2? And they would say, well, 6. Let's see if we did that right. But I want them to see it. It's about them having the understanding of why the standard algorithm works. So 1, 2, 3, 4, 5, 6 in each group. That's correct. So I put 6 tens. That's also why I'm putting it above the 2. It's all in the tens place. It has to do with place value. And I have the value of 6 tens times 2 is 120. And I should have 4 left over. And I do. So how many ones can I put in each? If I have 4 ones, how many can I put in each group? 2. So we put the 2 there. 2 times 2 is 4. And there you have it. Okay. I would do several problems, maybe a whole day of writing all of these, writing their actual place values down. You may not have to do this for more than a couple of times, because then you can ask students to do it, to draw it. I have 2, so I can do 100, 100. I got my 200. All right, well, I need to break this up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can mark all those off. And then 1, 1, 2, 2, and same problem. I just did it with base 10, brought pictures instead of the actual base 10. Okay. Then once you've done that, you can teach students the shortcut. It's all right, boys and girls. We put 100, and I would do it with as you're doing the pictures for a while. All right, so I'm putting 100. I have 3 hundreds. I can put 1 in each group of 3, or of 2. So 100 times 2 is 200, but what if I just put the 2 here? Because I'm just working with the hundreds. I have 100 left, right? But I can't put the whole 100 into my groups because I have to break it up into 10. So I'm going to go ahead and bring the 10s down. So I should have 12 10s, right? Is that what I have? I have 12 10s. Perfect. So let's put each of those 12 tens into the group. I can put 6, I have 12 of them, I can put 6 in each of the two groups, that is 12. So I have no more tens left, right? None? How many ones do I have left? I can just bring that down, right? I have 4 ones left. I can put 2 ones in each of the two groups, and that gives me 4 ones total, and I have nothing remaining. And this is efficient for some. Keeping their values is efficient for some. Doing partial quotients is efficient for some. So we're going to show this, but we're going to show all the methods that we've learned as we practice problems. I would encourage you for checking while you're doing division to make sure that students are doing division 2 different ways. So maybe partial quotients, then trying the standard algorithm, or partial quotients and doing the area model. That way they're practicing multiple ways until they find the one that they're most efficient with and the one that they like the most. Some kids are going to gravitate toward this. I also caution you, do not send home homework on long division until after Christmas, once students have mastered long division, because I want them to settle on the strategy that works best for them, not what their parents tell them to use at home. Because all parents are going to lead them to the standard algorithm. Why? It's because what's comfortable for them and it's what they know. They're trying to do the best they can for their student. And so to help them, if you send it home and they say, I want to use Magic 7 or partial quotients, and the parents are going to be like, what is that? What is your teacher telling you? But once they are able to use it efficiently and the parents see that they can do it efficiently, then they're not going to teach them a method or force them into one method before they're ready, okay? So I encourage you not to send home division practice with the different ways to divide until students have become efficient at it and can explain their process to their parents, all right? Okay, I think that's it for this video. In the next division video, we will talk about problem solving.